Welcome to the second video of Lesson 7, and this will be the final video in Section 1 of Unit 5. We will continue our look at adding fractions with unlike denominators symbolically. A point of interest. Thus far in adding fractions, you've been encouraged, in fact you've been instructed, to find the least common denominator, the LCD. And without a doubt, this is always a good practice. But it's worth mentioning that you can always find a common denominator by multiplying your two unlike denominators. And this too will allow you to add the fractions. However, this may or may not result in the least common denominator. And if it's not the LCD, please be sure to simplify your answer. And you will discover as we go through these next couple of examples the reasoning why we encourage you so much to find the LCD. So let's consider 3/4 plus 1/6. So we're going to work it out first, as we've been doing in finding the LCD. So if I look at my denominators of 4 and 6, if I list off my multiples of 4, 8, 12, 16, 20. If I list off my multiples of 6 is not common, but 12 is. So 12 is my LCD. So I'm going to write two equivalent fractions, one for 3/4 and one for 1/6, and these will now have a denominator of 12. Well, 4 times 3 gives me 12. 3 times 3 is 9. 6 times 2 gives me 12. 1 times 2 gives me 2. Denominator is the same. Copy it down. Add the numerators. 9 plus 2 is 11. And our answer is in simplest form. Let's look at the same calculation, but let's use the suggestion that was made here, multiplying your two unlike denominators. So if I take my 4 and 6 and I multiply them, 4 times 6 is 24. So I'm going to rewrite both 3/4 and 1/6 with a denominator of 24. It is definitely common. 4 times 6 gives me 24. 3 times 6 is 18. 6 times 4 gives me 24. 1 times 4 is 4. So I can certainly add. My denominator is the same. I copy it down. I add my numerators. 18 plus 4 is 22. Now, if you look at 22 over 24, however, that can simplify. So to reduce 22 over 24, what's the GCF for 22 and 24? That would be a 2. So I cut 22 in half, I get 11. I cut 24 in half, I get 12. And obviously, you got to end up with the same final answer as we do here, right? 11 over 12, 11 over 12. So a couple of notes that I'd like for you to take from this is that the numbers that you deal with in adding the fractions, if you don't find the LCD, they will tend to be a little bit bigger. And of course, we also had to simplify the 22 over 24 to get 11 over 12. Let's consider one more example to further investigate this idea. So we have a 5th plus 3/10 plus 7 over 20. Let's go the LCD route for the first simplifying. So I have a 5, 10, and a 20. If I list my multiples of 5, 10, 15, 20, 25, and I could continue on. My multiples of 10, 20, 30, 40, and I could continue on. And I don't need to list any multiples of 20 because already, look, well, except for the 20 itself, I have a 20, a 20, and a 20. So the LCD is 20. So I go back to my calculation. I will need to rewrite the 1/5 with a denominator of 20. I will need to do the same for the 3/10, but the 7 over 20 already has a denominator of 20. We leave as is. So an equivalent fraction for 1/5 would be 4 over 20, multiplying numerator and denominator by 4. An equivalent fraction for 3/10 would be 6 over 20, multiplying numerator and denominator by 2. Common denominator is 20. Add up the numerators. 4 plus 6 plus 7 gives us 17. 17 over 20, simplified, final answer. Let's use the idea that was presented on the previous slide with multiplying denominators here for the second time around. So I have a 5 times a 10 times a 20. You multiply those numbers together and you will get 1,000. So what I'm going to do is rewrite each of these fractions with a denominator of 1,000. So it is common. So an equivalent fraction for 1/5. Well, 5 times 200 is 1,000. So 1 times 200 is 200. 10 times 100 is 1,000. 3 times 100, 300. 20 times 50 is 1,000. 7 times 50 is 350. And by now you should be saying, oh my goodness, these numbers are so much bigger than what we just dealt with. And yes, that's the reason why we encourage you to go for the LCD. But we can continue on. Let's not stop here. So, common denominator, 1,000. Add up my numerators, 200 plus 300 plus 350. That gives us 850. And 850 over 1,000 is certainly not reduced. It's certainly not simplest form. And if we think about it, 50 is the largest number that will divide nicely into 850 and 1,000. And then that will give me the 17 over 20. So yes, we do end up with the same answer. And yes, you can do this question in this manner. But we encourage you to go for the LCD to make your life easier. And we'll end off here with a little word problem. So during elections for student council president, Chang received 1/5 of the student vote, 1/4 of the students voted for Samara, and 3/10 voted for Dakota. We want to know what fraction of the total student population voted. So this would involve a calculation of adding up 1/5, 1/4, and 3/10. And we are going to go the LCD route. To figure out the LCD for 5, 4, and 10, you will discover that it's 20. So I need 3 equivalent fractions here with a denominator of 20. 5 times 4, 1 times 4. 4 times 5, 1 times 5. And 10 times 2 is 20. 3 times 2 is 6. Common denominator is 20. Add the numerators. 4 plus 5 plus 6 is 15. And we do need to reduce here. 15 over 20 is not simplest form. The GCF for 15 and 20 is 5. So I divide numerator by 5, denominator by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. That is simplest form. So therefore, that's your little symbol for therefore, by the way. 3/4, 3/4 of the total student population voted. And now I would like you to proceed to the activities for Lesson 7.